Hello and welcome everyone. So in this video today, we are going to be providing solution to a Crackme challenge which I got from this GitHub repository over here. Alright, so all you have to do is to just download this zip file here, and then once you have it downloaded, come over here and extract the file. Okay, so we have after extraction you're going to have four files, one, two, three, and four. Okay, so for this video we are going to be focusing on the first one here, crack me one, and then in subsequent videos I'm going to be treating this and this. Okay, so I have my debugger up and running, so I'm just going to come to file, open. Okay, so I'm just going to select the first one here and click on open. Okay, so we have the program loaded into our debugger. All right, so but before we start running it, let's see what we are up against. Okay, let's see what we are up against. So I'm just going to run the program. Right. So you can see that the program is expecting us to find the secret password. Okay. So what are we going to do now? I'm just going to come to my debugger over here. Now, before you start solving this kind of challenge, what you have to do is search for strings first. Okay. So I'm just going to right click and come to search for. Okay. Click on all modules and come to string references. Now, the reason I said you should start looking for string first is because you know this is a challenge, all right? And when you find the secret key, it's just going to display a message, congratulations, or something like awesome. Okay, so from the string references we have here, we have some couple of strings here. Crack me 1.0.0, congratulations, you found the secret password. And also we have here congratulations, and then we have find the secret password. If you notice, that was displayed when I clicked on the help button. So let's check that out. All right, so we now know that this is for the help button. This string here appears whenever you click the help button. All right, so the one that we are supposed to focus on now is the congratulations, you found the secret password. And why did I say so? Now, you know, whenever you supply a password, the program is going to compare it with the one it's expecting, and whenever the match is going to display the message, congratulations, you found the secret password. So with this, we can now walk backward. Okay, like back from where this message appears. So if I should click on this, I have it over here. So the message appears here at this line here. Congratulations, you found the secret password. Now this should give you a hint that from this place upwards, like from here backwards, um you will be able to find the password this particular program is expecting before it displays this congratulations, you found the secret password. So our focus should be from this particular line here upwards. Okay, so we are going to work from this place downwards. Okay, so one of the things I normally do one of the things I normally do is to first of all set a breakpoint at the function where the message appears. Congratulations, you found the secret password. Okay, so what I'm going to do now is to set a breakpoint here so that we are going to start working from here, from this point, sorry, over here, from this point down to where we have this congratulations here. We are going to be able to decipher or get the secret password this program is expecting. Okay, so the first thing we see here, the first I think from here down to this place here, I think that's what we call prologue. Okay, prologue is just what a program does behind the scene for setting up the stack. Okay, that is where we set up the stack. Then we have the epilogue. which I call stack cleanup. Okay, whenever a program has finishes executing, it needs to clean up the stack, like its stack frame. Okay, like the local variables and other data stored in the stack is going to is supposed to clean it. All right, so we call this epilogue. All right, so this is epilogue. So where we up the registers and also move the base pointer value back to the stack pointer value. Okay, and then we return to the caller. Okay, so I'm just going to come over here. Come here. You can either come to breakpoint. Okay. Now we don't have a breakpoint yet, so come here. Right click. Okay, breakpoint, and then can toggle that on, or you can use your F2 key on your keyboard. All right. So this is it. So we have our breakpoint here. So what this means is if I start running this program, it's going to run up until this point, and this is where it's going to stop to allow me to be able to step through the program execution flow one after the other using step into or step over. Okay, so step into allows you to step into any function it finds along the execution flow. Okay, so if there's a function or a function call, it goes there for you to be able to know the content of the function's body and then carry out your examination. Okay, but for step over, it steps over any function call, so that is when you are just concerned with the return value of that function only. You don't want to see the body or the content of the function. Okay, you make use of what step over. All right, so I'm just going to execute this program right now. All right, so I supplied Sorocon 1, 2, 3, and we are now at our breakpoint. Okay, so let's start moving one after the other to sorry, let's start moving or step into the functions one after the other. So let's move. Now, as I am moving down or stepping into the execution flow of the program, my eyes are currently here. This is the register pin, and here is the stack pin or stack section, and then here is the memory dump. But here is the assembly output of the program. Okay, so just know this is the assembly output. This is for the registers, and this is for the stack, and then here's for the memory dump. Okay, so I will be watching the register, the stack, and also this particular section we have here and what we have here also, right? So just know that this is the registers. So these are the registers, and these are the values stored in each of the registers. And here is the value stored in each of these registers. Like the debugger tries to reference or to decipher the let's say the string representation of the content of these registers over here. All right. So let's keep on moving. All right. So I supply Stodacon 1, 2, 3 as the password. Okay, so we have it here. So my what I supplied, my input is being moved from this point here, this location, into the EAS register. Now we can't see that reflected here, but if I should move down a couple of times, you are going to see it here. All right, so we now have it here. Stodacon 1, 2, 3, right, has been copied, or sorry, it has been moved into the EAS register. Okay, so let's see. Okay, this looks somehow strange. 2925356A. Let's check our string references to see if we have that. 3925. Okay, nothing like that. We don't have anything like that. All right, so let's go back there. This looks somehow strange. It's moving this constant into this location on the stack. Okay, so this is not just register or something on, do you understand, but just like a location, a stack. Okay, this is the stack segment and this is the base pointer. So what this means is 20, all these values we have here, 20, 1C and 1A, these are in hex. Okay, hexadecimal. So 20 here in decimal means I think that should be 32. Okay, so this means move 32 byte below down the stack. Okay, and here also means move 1C down the stack and 1A down the stack. So let's see what 1C and 1A means. So I'm just going to open my calculator and go into programmer mode. Okay, so let's check what 1C and 1A is all about. So hex 1C. So 1C is 28. Okay, so this means move 28 bytes down the stack. What of 1A? So 1A means move 26 bytes down the stack. Okay, so we now know what that means. But this is looking somehow strange. Let's find out. So the value is stored on the stack, right? Okay, let me just move down before we see the value reflected on the stack here. So I'm just going to move down. Okay, so we have it here right now. So I'm just going to double click. Yeah. I said it. This was looking somehow suspicious. Okay. So this is stored in little endian format. We have little endian and big endian format. Okay. So this is stored in little endian format, which means the least significant bytes are stored first. Okay. So we now have the ASCII representation here as 9 modulo 5J. Okay. Let me see. ASCII. Let's look for ASCII, an ASCII table. Okay. Okay. I think I'm just going to go with this one here. Let me just select images. Let me go with this one. Why is it not popping up? Okay. So let's go to visit. At the same time, I'm going to. Okay, I'm coming. All right. So let me just increase my screen. Okay. So what do we have there? We have 9 modulo 5J, right? 9 modulo 5J. So what do we have there? 3, 9, 2, 5, 3, 5, 6A. Okay, as 9 modulo 5J. Okay, so let's see the ASCII values of those. See if it is correct or if we are correct. Okay, so what is 9? 9 here is 39. Okay, we have 39 here. The modulo is 25. Okay, that's correct. We have 5. 5 is what? 5 is 35. Okay, that's correct. And then we have 6A. 6A is let's see, 6A, 6A, 6A. Yes. Okay, I have it here. All right, so 6A here is J. Okay, so that's correct. We have J here. Okay, so let's go back to our debugger and see. So this constant is not just a constant. These are ASCII representation, like the ASCII hex value of these characters we have here. I know each character is 1 byte or 8 bits in size. Okay, so cancel. Now let's see what's going on there. So now, like I said, a character is 1 byte. Okay, 1 byte in size or 8 bits. Okay. We now have this operation here. Move d word. Now d word stands for double word. Okay, double word, and a double word is 32 bits or 4 bytes. Okay, so this is moving 4 bytes of data into this where is it, into this location on the stack. And what are those 4 bytes? These values we have here, or this one, what we have here. And like I said, a character is what, 1 byte in size. So we have 9 here as 1, modulo 2, 5 here 3, j 4. So that means 4 bytes was moved. Okay, of the second part here, we have 6B, 6C. Let's see. 6B, 6C. Okay, let me move down again. All right, so let's double click 6. Okay, we have .vkl, 6B, 6C as .vkl. Okay, .vkl. So let's move that here. .vkl. What is 6B? Okay, 6B, 6C. 6B, 6C. So I'm just going to check 6B, 6C. What is 6B? Okay, 6B here is K and 6C is L. All right. So this is making sense. So we have that's what .vk and what's going on here. This is moving a word, and a word is 16 bits. A word is 16 bits, okay, or 2 bytes. All right. So this is moving 2 bytes, which could be .v or .al into this memory location on the stack where we have it here. That is 1C. I think 1C is 26, right? 26 bytes. Yeah, one C suppose. Let me see. 1C, yeah, 28 bytes below the stack, and then we now have something here moving 0. This is moving 0 to I think 1A is 20 what? Let me see 1A. One is 26 bytes, so it's moving 26 bytes below the stack. It's moving 26 bytes below the stack, okay, into this location here, 26 bytes, okay, into this location on the stack. So from what I'm seeing, this looks like a null pointer, okay. Sorry, it looks like a the null character or the null byte. So a null character is what we use to terminate a string in like, C programming or C++, okay. Like in computer strings like let's say John or Stodacon, they end with this null byte or this null character, okay. So the representation is 0 on the ASCII table. Let's see. Okay, null, you can see it's a null 0, okay. So it's so this is just making sense because from what I'm seeing right now, is moving a byte, okay, and like I said, the character is 1 byte, so it's moving a byte, and this null pointer is 1 byte in size into this location, 26 bytes below the stack. Am I correct? 1A. Yes, 26 bytes below the stack. Okay, so this, from what I'm seeing right now, these three things, 1, 2, and 3, is just the program trying to compute, so I'm trying to arrange or create a the password, like a string for the password at runtime, and that was the reason we were not able to see uh these strings here, 9 modulo 5j. Okay, so this is done dynamically while the program is running. All right, so let's see. So once it moves that into this location here, what's happened next? Let's move down. Okay, and it loads the effective address at this particular location, because this is the start of this string here. These strings, where are they? VKL 9 module 5J. Okay, so the 3925, the 56A, okay, they are stored in this particular, sorry, in this location on the stack. So this is the start of the address for this string. So it loads that into ECX, and what happens next? Let's move down. Okay, so once it loads it into ECS, then it now moves a byte, okay, like one character, into the lower 8 bits of the EDX register known as what, DL. Okay, this is the lower 8 bit. Okay, and why do I say so? We have EDX, okay, for 32 bits, all right, and then we have RDX for the 64-bit registers, right? So we have these as like this DL, we have DL and we have DH, okay. So these are 8 bits, okay, and then these are also 8 bits, okay. So this is for what? The two registers. Sorry, this EDX is for what? These are 32-bit registers, okay. Any register you see starting with E, they are what? 32-bit registers, and anyone you see starting with R, that was 64-bit registers, okay. 64-bit registers. All right, so we also have 16-bit register like DX, CX, okay, something like that. All right, so and the 16-bit registers are a combination of DL and DH, or let's say the name of the registers, okay, that they are split into two. So 8-bit plus 8-bit will give you what, 16 bits. So the lower 8 bits, which is DL, now has the value of my stored account 123 password, right? That is, the S letter here is copied into the DL and compared with the first byte of the password J5 modulo 9LK, which means it is comparing S and J character by character, okay? SJT5. All right, so let's see how it managed to change these three things here into J modulo 59LK. Okay, so let's see that now. If we before we solve this, I need you to know something. This value, these strings are stored what, on the stack, okay, and stack is what we call LIFO, okay, last in first out, last in first out. So this means that any value you push into the stack will come out last, what, and anyone you push in last will come out first. So if I should have something like 66 and then 77 and then 88, if I'm to pop any of them out of the stack, I need to start from the top. So the last one here will be first popped out, followed by 77, followed by 66. Okay, so let's see how this works here. All right, so what it does now, remember all these things are stored in little endian format. Okay, so when the computer or the program, yeah, something like that, wants to interpret it, it rearranges them properly in memory. Okay, so what we have here now is this. How did we get this, or how did the program get this? All right, so in reverse, it started popping 6A from the stack, so we have J starting from behind. Okay, then it popped 35, which is 5. Then it popped 25, which is the modulo, and then it popped 39, which is 9. And then remember, it now went below again and then copy 2 bytes. Remember, we copied 2 bytes here. Where is that? Here. Move word pointer 6b6c, and 6b6c is what? K and L. Okay, so it now start from L. So we now have L, then K. And since we only moved 2 bytes, these ones here we're not moved, so we'll move that. So we now have J5 modulo 9 LK. Okay, so that's how it did this. So it's going to compare this character by character. Okay, all right. Now, if you notice something here, I think it only compare. Let's see. Okay, yes. All right. So it does that, and then we now have congratulations if they match. Okay. So what we are going to do now is to know. Okay, it only compares characters S and J and only 3 and 5. It doesn't go ahead to compare the remaining ones. I think this is for if this is for efficiency. Okay, something like if the first two characters don't match, then just end the program. That is not the correct password. So it just checks the first two characters, because here we have S and J, and then we now have T and 5 here. All right, so let's see if we are correct with what we have here, J5 modulo 9 LK. So I'm just going to run the program. All right, so you see, we definitely cracked the challenge. All right, so thank you for staying with me up to this point, and please give yourself a sound clap. All right, so please, if you know you've not subscribed to my channel, please just do it to turn on the notification bell and also hit the subscribe button so that I don't get to miss any of my videos or the next video, which I will be working on Crackme 1B, Crackme 3, and Crackme 2. All right. Thank you, and see you next time. Bye.